This is a demo of our G4 project. We have the filter right here, which has charcoal on the bottom, sand on the top. Both are used to filter this undrinkable pond water. So if we place the filter in this holder and we take our sensor, water sensor, place it inside that, so like this, and we can take some of our pond water, just pour it till it fills to the top. So now, slowly, as you can see, water is being filtered, and in some time, the water should be completely drinkable. This is just a quick walkthrough of the code that I wrote for the filter. So at the top of the filter, we had a sensor called the potentiometer, which senses certain elements in water, and we used it on the fish pond water that I took as my sample. So this fish pond water comes from my community's fish pond, and obviously just by seeing the yellowish tint color, you can tell that is not drinkable. So if we run the code, it scans the water and it asks us if we would like to see our results. We hit yes, and it'll tell us what elements are present in the water. So high are phosphorus, carbon, and nitrogen, which are obviously going to be present in like swamps or places where there's lots of algae and other bacteria and microorganisms, which is also true for the next row, which is elements that are present but not that high. You have bacteria, microorganisms, and minerals. However, zinc and copper are both absent, which would obviously make this water healthy. Therefore, my code is able to make the conclusion that the water is not drinkable. As you can see, the water has been filtered, and if we just take a look at this, there is some debris, but it is much more clear, and it is looking a lot more drinkable than its counterpart, the original pond water. The debris is just caused by inefficiencies in the filter itself. So if we take out the filter, as you can see, the filter is relatively small. It's around this big, and that is the reason why there still is some debris left in this cup. If we made this filter much bigger, meaning there is more surface area that the original water has to go through to become filtered, it would be filtered much more efficiently. So that is one place where we can improve this experiment. But since this is just a quick demo, I decided to make the filter, I guess, smaller. So for the final step of this demo, we have to check whether this water is drinkable or not. And we will do that by placing the potentiometer into the water and checking the code. This is the final part of the code. So we have the potentiometer into the filtered water, and now it is currently sensing what is there in the water. We can use those results to check whether the water is drinkable or not. That is the purpose of this segment of the code. So if we hit run, it asks us, is the sensor in the filtered water? We type yes, and then it scans. After it scans, it tells us what elements in the water have been removed, reduced, and what have remained. So removed, we have the bacteria and the microorganisms, which have been completely removed. And then we have reduced, meaning there still is a little bit of these in the water. Phosphorus has been reduced, the nitrogen has been reduced, and the debris has been reduced. All of these are visible just by the change in the color, and I guess you can kind of see through the filtered water. It's more transparent compared to the pond water. Finally, two elements have remained, carbon and minerals. Carbon may not be a good thing to have in your water, but the minerals, it's a good thing that they stayed. Although carbon is still present in the water is drinkable now compared to its previous pond water. So this filter clearly works. As I said previously, we can improve this by making the filter bigger, by adding finer, finer pieces of sand, more charcoal, and just increasing the area through which the water has to go through in order to get filtered. So this is just a small demo of our filter, and hopefully this can be used to help places that are impoverished and may not have drinking resources in the future.